Welcome back, everybody. We are looking at Part B of Exercise 1 on page 33 in the workbook here. And the instructions on this exercise are the same as in the previous video. They're giving us a vector space V, in this case R4, and a subspace W, and they'd like us to find a basis for the subspace W. Okay, now here's the thing. We have a very nice technique for finding a basis if W is presented to us as the span of a set of vectors. But in this case, W is presented in a little bit different of a form, and so our strategy here is going to be to try to rewrite W as a span of a set of vectors, and then to use the technique that we've been using. Okay, we can take our first step to doing that by noticing, okay, that this equation, it's kind of describing how the coordinates in our tuple have to behave to be in the set W. We can rewrite that equation by just solving it for A. Okay, so if you solve for A, you can basically just add the other three terms to the other side. So A is going to be B minus 3C plus 5D. Okay, so a way of rewriting W is just to say it's going to be the set of four tuples where the A, the first coordinate, has to look like B minus 3C plus 5D, and the last three can be anything they want. Okay, so B, C, and D are just any real number. And that's just a way of rewriting our set W. Okay, and now what we're going to do is an algebraic technique that's very useful in a lot of problems where you're trying to find a basis. So this is a good example to maybe keep in your back pocket and use as a guide, okay, in a lot of problems where you're being asked to find a basis. Okay, so what we're going to do is to pull this coordinate apart. Okay, we've got a four tuple. We're going to look at it one variable at a time, starting with, okay, I'm going to just erase this so this doesn't get too cluttered. Starting with the b's, let's underline every instance of b that we see. There's one and there's one. Okay, one b in the first and the second coordinate. So we'll start out by writing b, b, 0, 0. The zeros just tell us that there were no b's in the third and the fourth coordinate. Okay, then we move on to the c's. Notice that there's a minus 3c there and a c there, okay, in the first and the third coordinate. So negative 3c in the first coordinate, no c's in the second coordinate, a c in the third coordinate, and no c's in the last. Okay, and then finally, what about the d's? Well, we've got a 5d in the first coordinate and a d in the last coordinate. So that's going to give us a 5d, no d's in the second and the third coordinate, and then finally a d. Okay, you could take a minute just to convince yourself that if you took these three vectors that we wrote down and added them up, they would give you this. Okay, so this set is really the same. We haven't changed it. All we've done is pulled that four tuple apart. Okay, now here's kind of the critical step, noticing we can do one more algebra step here and factor these variables out. So BB00 we can rewrite as B times 1100. Okay, pull a C out of the second one, we get negative 3010. Okay, and then pull a D out of the third one, and we get a 5001. Okay, and here's the critical thing here. Notice, if you look carefully at this, the way that we've written our four tuple in the last set is it's a linear combination of these three vectors. So by definition, this is the span of the vectors that I just underlined. Okay, and remember, that was our goal, was to take this presentation of W that they gave us and to rewrite it as the span of a set of vectors, because we know how to find a basis of a vector space that's given to us in that form. Okay, so now we're ready to apply our general principle. So we'll build a matrix that has the three vectors as its columns. Okay, and this time I'm just going to jump to the last result. So if you do row operations on this, you can, again, either do this by hand or on a calculator. Here's what you wind up with for your echelon matrix. Okay, and if we circle our pivot positions, we get pivot positions in every column in this case. And so, let's say it this way, by the row operations above, okay, we see that we need to select all three of these vectors to get a basis for our vector space. Okay, so beta equals -3010 and then 5001. That's a basis for W, and since there are three vectors in that basis, the dimension of our subspace has to be 3.